So this question is definitely going to come in your exam, so I need you to pay attention. So what you're going to learn exactly here from this video is how to find the equation of a hyperbola, so a hyperbolic function. So you're going to learn how to get an A, how to get a Q, and how to get a P. And lastly, so stay tuned for the 5.5. So this is your bonus question that I'm going to do with you. Okay. So we're still doing grade 12, mathematics paper 1, November 2024. So for this video, we're doing question, question 5. Okay, great. So we're doing question 5. So this is all about hyperbolic functions. So what you need to know here really is this. You are given that g of x is equal to x minus 3. So that's g of x. So you're already given that. And of course, if this is minus 3, so therefore your y-intercept of g of x is minus 3. And what else? We told that the y-intercept of f is 0. So we are told that f of 0 is equal to 1. Okay. Remember, you're just given an equation. So we're told that this part here, the y-intercept is equal to 1. And what is being told here? And also we're told that the vertical asymptote x is equal to 1. So this is your vertical asymptote, x is equal to 1. Your horizontal asymptote is equal to q, of course, right? Remember that your horizontal asymptote is equal to q, and your vertical asymptote is equal to if it's x, if your vertical asymptote, if it's x plus p, this is equal to p 0. So your x is equal to negative p, right? So based on this, your x is equal to negative p. Make sense? So from here, you can actually able to find p. And what else are we given? I want you also just to remember that even though you're being told that this function g of x is equal to x minus 3. However, there's something called axis of symmetry. So axis of symmetry is this line here, this line, and that line over here. These are axes of symmetry. So we know that the formula of this axis of symmetry is y is equal to x plus q minus p. Okay, and this line here, which is an axis of symmetry, is also y is equal to minus x plus q plus p. Okay, and from here I think we can able to answer a couple of questions. Okay, so let's go to 5.1. So 5.1 says write down the value of p. So I mean, this is easy, right? Because now we already know that x is equal to 1 and x is equal to minus p, right? So if x is equal to 1 and x is equal to minus p, therefore minus p is equal to what? 1. So therefore p is equal to negative 1. So p is equal to negative 1. Does it make sense? So let's go to 5.2. Determine the equation of a horizontal asymptote. But you see that just before you answer your question, it is better to analyze your whatever that you're given, write it down, figure out what you know, what you don't know, before you jump to answering questions. Because when you jump to answering questions, you know, if you've already figured out what's going on, it's easy to answer the questions, right? So for example here, determine the equation of a horizontal asymptote of f. Think about this. So this is a horizontal of f, okay, the horizontal asymptote, which is y is equal to q. However, this touches at this point, and we know the x value of this point is equal to 1, and it touches what? This axis of symmetry, which is equal to this, but it's already given as x minus 3. So if I substitute the x value, which is 1, I should get what? This y value, which is q. So what I'm saying is you are given g of x is equal to x minus 3 Okay, so we're saying y, which is equal to q, is equal to g of 1, right? At this point here, this is where we can get the y asymptote, or the horizontal asymptote. And so how do you get your answer? So y is equal to, so where there's x, we just put 1, so it's going to be 1 minus 3. So y is equal to negative 2. So your y asymptote is equal to negative 2. So meaning our q is negative 2. Right, so we have p, we have q. Now let's figure out what is a. Okay, so we have q and p. Let's figure out what is a. So to find a here is really not that difficult, because you have, let's go to the function. F of x is equal to, let me use blue. F of x is equal to a over x plus p plus q. And remember, we know p is equal to -1, and you know q is equal to -2. Okay, then what do we know? We know this information here, right? Where this y intercept, where x is 0, the f of 0 is equal to 1. So this y intercept here. So what you're going to do is you're going to just substitute it in this equation. So you have a over, where there's x, you put 0, minus 2 is equal to 1. Then you're just solving for a. So you're going to have a over -1 minus 2 is equal to 1. Just take the negative 2 to the right hand side, becomes positive 2. So you've got 8. 8 divided by -1 is just negative a. This is equal to 2 plus 1. Negative a is equal to 3. Therefore, a is equal to -3. So your a is equal to negative 3. So what do you have? You have now the final function is -3 over x minus, what is p? -1 minus 2. That's your final function. Okay. Okay, cool. Let's go to 5.4. Now, here they say, for which value of x is f of x greater than 0? So, or equal to 0. So now you see that the values of x were f of x greater than 0. F of x, this function here, is greater than 0. So it's above this line, where? Here. So from here, okay, to here is above the x-axis. It's positive. It's greater than 0 from here to here. Okay, so that's what you're going to be doing. So we need to figure out what is this line here. What is this line here? What is this line here? And of course, this line, where does it touch? It touches at your x-intercept. It touches at your x-intercept. And so basically what I'm saying is, we're saying f is positive between this point to here. We're saying x is positive. If I write it down quickly, we're saying f of x is greater or equal to positive if x is greater than or equal to this point here. Let's call it x 1, and less than 1, right? And less than the, because remember this is 1 at this point, and it's an vertical asymptote, so it doesn't touch it. It's always going to be approaching the vertical asymptote. So that's why it's less than, not equal to, because it's not going to touch it. But it is greater than this point, and we need to figure out what is this point here, which is the x-intercept. Okay, and what do we know? We know that this is an x-intercept, so we know that f of x1 is equal to 0. Why? Because it is an x-intercept. An x-intercept, you let y is equal to 0. So you have f of x is equal to -3 over x minus 1 minus 2. So f of x1, which is the point that you're looking for, It's going to be, where there's x, just put x1 minus 2, right? And what do we say? We said f of x1 is equal to 0. Why? Because in the x-intercept. So this is equal to negative 3 over x1 minus 1 minus 2 is equal to 0. And then we just solve for x1. So you have negative 3 over x1 minus 1. Take 2 to the right hand side, become positive 2. And then if we do the reciprocal of this, it's going to be x1 minus 1 divided by negative 3, which is equal to 1 over 2. We're just flipping up the equation or the function. And then you just cross multiply. We have x1 minus 1 is equal to negative 3 over 2 if you cross multiply. Therefore, x1 is equal to 1 minus 3 over 2. So x1 is equal to 2 minus 3 is minus 1 over 2. So your x1, which is this x-intercept here, this is equal to, x1 is equal to negative half. What are we saying, therefore? We said it is positive here. So it is positive when x is between negative half and 1. Negative half and 1. So your answer is x is positive when is equal to negative 1 but less than half. Or is greater than negative half but less than 1. It doesn't touch 1. So that's why we don't say greater or equal to. Right, so this is how you would essentially answer a hyperbolic function. It's always going to come in your exam. You always have to understand how to write an equation from a given sketch or a graph. And now I'm going to jump into a bonus question. So this is where students who want to get a total and the student doesn't want to get a total. So if you don't want to get a total, I advise you to jump off the call and give me a like. But yeah, give me a like. But if you want to get a total in your final exam, let's do 5.5 together. So let's go. So 5.5 says the graph undergoes a transformation to H. Okay, so the domain and the range of H are the same as F. So what is the domain of F? So the domain of F is X, an element of, if you look at F, the domain of F, we're looking at the axis, and you see that it goes from infinity, and then when it goes to 1, it's almost skip 1 and start again, and it goes to infinity. So the domain of F is from negative infinity to 1 union 1 to infinity. Okay, so meaning what is happening is it goes from negative infinity, and when it reaches 1, it doesn't touch 1, but it skips 1 and it goes again to positive infinity. And same applies with the range of F. The range of F, again, it goes from negative infinity. When it touches which is negative 2, it's jump negative 2 and goes up, right? So the range of F is from negative infinity to 2 union from 2 again to infinity. That's basically how you write a range of any hyperbolic function or a domain of any hyperbolic function. So we're told that F and H, they have the same range. Okay, that's what you're being told. And then we're being told now that the derivative of H is it's negative on its domain. So meaning it is flipping, or it is being reflected somehow. It becomes negative on its domain. Okay, so meaning, what does this really mean? It really means that at its domain, it becomes negative. So in its domain, this domain is being affected. So it's not gonna look like this. It can look differently, but in this case, it can look, so meaning we still keep the range, but the domain is affected. So that means we still keep the range, so it still goes from negative infinity to positive infinity, but the domain is affected. So we get, it has to be like this. So it had to reflect at x equal to 1, and you have a new one like that. So we have let me grab this. So we have this and that. So what's going on is for f to transform to h, they have to reflect at x is equal to 1. Right. So what's the question? Describe a possible transformation that f could have undergone to result in h. So a possible transformation here really is what I just told you, that for f 5.5, for f to transform from f to h, the transformation it has to undergo is you have to reflect at x is equal to 1 at the vertical asymptote. It has to reflect as vertical asymptote, therefore becomes a mirror image of each other. All right, so let me know if you understand 5.5. It's such an amazing question. And however, the very important question is from 5.1 to 5.4. These questions always come into your exam. And I hope to see you in this video. If you like this, make sure you share with your friend. Write a comment if you got questions. And leave a like if you actually find value from this video. And I'll see you in the next question, which is 5.4. And this is your homework. If you want, you can clip this and do it yourself, but you find it on the next video. Boom.